Hello and welcome to Honors Precalculus T1 Day 18. Today we're going to talk about angles and their measure. And there are two ways to measure angles. These are the two ways we're going to use. The first way is using degrees, and the second way is going to be using radians. So what we're going to do first is convert something that's measured in degrees into minutes and seconds. These are the fractional parts of a degree. So the first part is the number of whole degrees. So it's 37 degrees. So there are 37 degrees. And then there are 60 minutes in 1 degree. So what you do first is you multiply what's left. You multiply the 0.425 times 60 to get the number of minutes. And when you do that, you end up with 25.5 minutes. And that's what that little mark means right up here. That's what that little mark means, minutes. So what we have now is 37 degrees and 25 minutes. Now, as you might suspect, there are 60 seconds in 1 minute. So there are 60 seconds in 1 minute. So what we do next is we take this fractional part, so 0.5 times 60 is equal to 30 seconds. So what this means is 37.425 degrees is 37 degrees, 25 minutes, 30 seconds. The next thing you might have seen before is the idea of the circumference. The circumference of a circle is the distance all the way around the circle. We define the distance from the center to the outer edge of the circle to be the radius of the circle. And the formula you might have seen before is circumference is equal to 2 pi times the radius. 2 pi times the radius. What you actually see here are dots around that represent one radius. So actually what you get here is this distance right here is one radius. That's one radius of the circle. That's another radius of the circle. There's another radius of the circle all the way around. And if you might remember, pi is a little bit more than 3. So 2 times a little bit more than 3 is going to be a little bit more than 6. So you see there's a little bit more than 6r all the way around. And that's the definition. So that's about 6.28r. But as we know, pi is 3.14159. It goes on infinitely without pattern. So you can keep on going. But there are a little bit more than 6 radiuses all the way around. And this is the formula you absolutely need to know. The arc length is a fraction of the circle, a fraction of the, specifically the circumference of a circle, a fraction of it. So one way to write it is theta over 360, if this is in degrees, times 2 pi r. 2 pi r is the circumference, remember. This is the circumference, and this is the fractional percentage of the circle, but this right here would be in degrees right there. This is in degrees because there are 360 degrees all the way around one circle. Now the area of a sector, so arc length is around the edge of a circle. Like for example, this could be that could be the arc length for a certain part of the circle. The area of a sector is the area of the pi wedge. What I mean by that is you might have the arc length being from here to here, for example. What is the area here of this pi wedge? That's what it means when it says the area of a sector. It's a fraction of the area of a circle. Fraction of area of circle. What that's going to be is the area of a sector is theta over 360. That's the part of the circle, like the percentage of the circle, times pi r squared. You might have seen that before. This is just the area of a circle right there, and then this is the fraction of it, the percentage of it. So the area of the sector is this whole thing right there. So this question is asking to find the arc length and the area of the sector of a circle of radius 10 and out by angles that measure 180 degrees. So remember, the r in this case is going to be 10. So what is the arc length going to be? The arc length is going to be, remember, theta over 360, this is the formula, times 2 pi times r. So in this case, the r is 10 and the theta is 180. So that's going to be 180 over 360 times, not equals, times 2 pi times 10. So that's equal to 1/2 times 20 pi. So that's equal to 10 pi. And you can put that into your calculator to get a decimal. That's around 31.416. I love 3 decimal places. 3 decimal places is awesome. So what would be the area of the sector? Like if you had a sector of a circle that's 180 degrees wide, so that would be actually 180 degrees is that much. The area of that sector by the formula that we had up above is theta over 360 pi r squared. So that's going to be 180 degrees over 360 times pi times the radius squared. So that's 10 squared. So that's going to be equal to 180 times 100 over 360 pi. And if you cancel these things out, you end up with 50 pi. 50 pi. So that's the area there. So again, over here, if you want the arc length of 225 degrees, it's going to be 225 over 360 times 2 pi times the radius. And if you do this out, you end up with 12.5 pi, which is about 39.270. But if you want the area of the sector, this is the area of the sector, so the area of the pi wedge, that's going to be 225 over 360 times pi r squared. That equals, if you do it out, it comes out to be 62.5 pi, which is about 196.350. Again, it's not exact, but I love 3 decimal places. Now there's this concept of a radian, and this is when we're dealing, well, not with degrees, but with radians. If a circle has, remember, a radius of r, so this is our r right here, if you take that same distance, so we're taking this distance right here and lay it onto the circle itself, so this distance is r. If we make this distance r equal to the radius, this angle measure right here that's created is called 1 radian. So the amount, the number, like the amount of the circle you get by placing the r onto the edge of the circle is equal to 1 radian in angle measure. So the way you would say that is the measure of the central angle formed by, quote, laying off, which is that putting that radius right there, 1 radius along the circumference of a circle. That's 1 radius. Now you might remember that I showed you that for on the area, the circumference of a circle, remember the circumference is 2 pi r. So you end up with radian, 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 2 pi r, 2 pi radians all the way around, 2 pi radians all the way around. And therefore you know that 360 degrees is equal to 1 full rotation. And 1 full rotation in radians is 2 pi radians. 2 pi radians is equal to the same thing, 1 full rotation. So what does that mean? It means that 360 degrees is equal to 2 pi radians. I'll write that as radians. So if we divide here, you could also say 360 degrees is equal to 2 pi radians. That's the key thing you need to memorize, because then it allows you to convert between the two. What does that mean? Well, first means that if you divide both sides by 360, you get 1 degree is equal to 2 pi radians over 360. All I did was divide both sides by 360. So what that means is 1 degree is equal to pi over 180. That's simplifying radians. And then similarly, if you divide by 2 pi, you end up with 1 radian. 1 radian is equal to 360 over 2 pi. So that's 1 radian is equal to 180 over pi. And we can use this to convert between the two things. If you're given radians, you can just put it in degrees and vice versa. So if we're converting from 10 degrees to radians, we're converting 2 radians, you multiply literally just by pi over 180. You multiply by pi over 180 to go 2 radians, and you get that from here. If you want to go 2 radians, you multiply by pi over 180. So you end up with 10 pi over 180. That cancels, and you're left with pi over 18. Pi over 18. Negative 135 degrees, you do the same thing. You multiply by pi over 180. You can simplify that to negative 3 pi over 4. And the same thing here, pi over 180, you end up with 3 pi over 2. And the reason we're multiplying by pi over 180 is if we want to turn the number of degrees into, say, 270, we'd multiply this thing by 270 as well. So that's why we're multiplying by pi over 180. Now, if we want to go 2 degrees, we're going from radians 2 degrees, we're just multiplying by 180 over pi. If you do that here, you end up with 135 degrees. And pi over 180, so 180 over pi, sorry, you end up here with 300 degrees. And 2, you're just going to multiply again by 180 over pi, and you end up with 360 over pi degrees. Now, it is possible to have pi degrees. It is possible. It doesn't happen that often, but it is possible. So here's something you can fill in on your own. And when you're going 2 radians, remember, go back up, you can look at the example here, you multiply by pi over 180. So all of these are getting multiplied by pi over 180 to get down here. So that one's still going to be 0, but then here, pi over 180, you're going to end up with pi over 6. And if you do the same type of multiplication, you take all of these right here, you take all of these top numbers here, all of them, and you multiply by pi over 180. There's x as multiplication. You end up with a table that looks like this. These are really important values for you to know, these bottom values right here. So degree value on top, radian in the bottom. Generally speaking, radian values will have pi in it. It's very common. So now we're doing the same thing again. We're finding the arc length and area of a sector of a circle of radius 10 cut out by an angle measure that's given. So what that means is we have a circle and the radius has 10 right there, and we're cutting out a sector that has an angle measure of pi over 2. Well, pi over 2 is 90 degrees, so it looks like that. So we're looking for the angle measure right here, and we're looking for the area of the circle. So the arc length and the area of. So we want the length of the arc and the area. In this case, the formula is theta over, same thing, but over 2 pi, because instead of degrees, we are in radians. This is a radian measure. So the only thing that changes is instead of 360, it's 2 pi. So to do this, we end up with theta over 2 pi times 2 pi r, and that's going to be the arc length right here. This is arc length. So in this case, we end up with pi over 2 over 2 pi times 2 pi times, and the radius is 10 right there. So what happens here, you get this a lot. These cancel right here, and you end up with a dog in the background making noise, but that's okay. Pi over 2 times 10, which is 5 pi. So that's the arc length. Now what's the area? The area is going to be very similar. It's going to be equal to theta over 2 pi, which is the part of the area of the circle. But what is the formula for area? Pi r squared. So in this case, it's going to be pi over 2 pi times pi times 10 squared, and you just have to simplify this. The pi's cancel. You end up with, in this case, 100 pi over 4, so you end up with 25 pi. So that's the area of this sector right here. That's the area of this sector. Similarly, 5 pi over 6, when you do this out, again, it's a radius of 10. 5 pi over 6 goes all the way to about here, so it's going to be a little bigger. That's 5 pi over 6, because pi is 180 degrees. So we're going to do the exact same thing. So for arc length, remember, it's the theta value over 2 pi. The 2 pi's cancel, and you're left with 50 pi, so 5 pi over 6 right here. So you can simplify that to 25 pi over 3. And then for the area of the sector, you're going to do something very similar, and you're going to end up with 5 pi over 6 over 2 pi, because that's the part of the circle right there, times pi r squared. That's a 0 right there. It's a 10 squared right there. So the pi's cancel. You end up with 5 pi over 12 times 10 squared. So you end up with 500 pi over 12, which is 125 pi over 3. That's the area of this right here. Area. Only thing that changes is the 360 becomes 2 pi, because remember, there are 2 pi radians equals 360 degrees. That's very important.